This video will cover the first part of section 3.5. We're not going to get too far on it, but I would like for you to watch this video because we will only have, well, my 7th-period students will only have Tuesday to cover this section, and then your test will be on Thursday. So this section involves exponential growth and decay models. So we're going to work on word problems. We're also going to work on some logarithmic word problems, and we will also visit the logistic function, which is something that you have not seen yet, maybe briefly in Algebra 2. So we're going to start with exponentials, and what we're going to do here is apply all of those rules that we learned through, from Chapter 3, how to condense, how to expand, how to convert from exponential to logarithmic, how to do a change of base. And we're going to do that to solve word problems. The hardest part here is that we will have to come up with our own equations. The equations are not going to be given to you. So the homework is going to be available today. If you want to get a head start and start working on it on the weekend, please feel free to do so. But try not to look at the examples too much, because that's not going to be good for your test. So we're going to start with the exponential growth and decay models. And for those, it is very similar to the continuous compounding formula. If you guys remember, that was A is equal to P to the times E to the power RT. And we use that one for continuous compounding, right? If you compare that to the other one, the compounding periods, it looks like something like this one. And then we kind of went over of how if you take the limit of this part as n approaches infinity, we get that this approaches e. You can look at that on one of your other sections. I'm not very sure about the number. Maybe 3.2. So anyways, we use e because that implies that it keeps going and going and going and going non-stop, right? So when we talk about problems such as population growth or bacteria growth, we're going to need to use that number, E. So if you see here, what we have for A sub 0 is going to be the initial amount. So A sub 0 is actually taking place of the principal, if we go back to that continuous compounding formula, the initial amount of money that you were to deposit there. So what we will have here is that if K is positive, that means greater than 0, then we're talking about a growing entity. And we have here the A sub 0 is the original amount or initial amount or the initial size or the growing entity at time 0 at the beginning. And also we have here that capital A, when we talk about problems about money, this A is, it could be the final amount. When we talk about that, we could call that the amount at certain time. So it's also the final amount. And also it's important to recognize that K is the constant representing the growth rate. Now when K is negative, we're going to be talking about a decaying problem, and so K will be the decaying entity. Same thing, A sub 0 is the original amount, or the amount at time 0. Capital A, without the subscript, it will be the final amount or the certain amount at time t. And K, of course, is the constant, which will represent decay rate, and that is if K is negative. And here you have a picture of both functions, one representing a growing entity, exponential growth. You can see here, this is the amount at time 0. And here we have exponential growth. On the other side, we have times the amount, the initial amount, times 0. And then, because k is negative, less than 0, that will be an exponential decay. So let's go ahead and solve this problem here. And who would like to read the problem? Okay, thank you, Bruce.
The graph in figure 3.22 shows the U.S. population in millions for 5 selected years from 1970 through 2010. In 1970, the U.S. population was 203.3 million. By 2010, it had grown to 308.7 million. Find an exponential growth function that models the data for 1970 through 2010, by which the year will be U.S. population reach 335 million.
Okay, so I apologize, I don't have the graph there, but I think we have everything we need on within the board problem. So first we're going to work on part 8, and we need to find that model. So remember, will this be exponential growth or decay? Growth, right? So we're going to be using this model. A is equal to a sub 0 times e to the power k times t. We don't know much about this. Well, we don't know the equation, but we have enough information to lead us to that equation. So we know that from years 1970 to 2010, right? So one thing that we're going to consider here is that the year 1970 will be t is equal to 0. So at that time, at t equals 0, the population was 203.3 million. So what we're going to say is that a sub 0, which is the initial amount, or the amount at time 0, a sub 0 is going to be equal to 203.3 million. So now, what we need to look for is for k. So if we look at this formula here, so far we have two things. We have a number for a sub 0, and we have a number for t, right? What will be the value for t? 40. 0. It will be 0. So we need one more, because we can only solve for, we still have two unknown variables, a and k. So to solve for two variables, we will need two equations. We only have one equation, so that means that we need to substitute one more variable with a numerical value. Now, that numerical value is going to come from here, 308.7. And now, in this case, we're not going to use t equals 0, but we're going to use what Karina said, 40. Right? Is that what you were talking about? Okay. Now, we're going to use 40, so what we're going to do is make our final amount be equal to 308.7, but with that final amount, the time will equal to 40. And why do we use 40? Because that 40 is the difference between the years 2010 and 1970. So if you subtract that, you will get 40. So that is why t equals 40. So now I'm going to go ahead and use all that information and substitute it into my formula. So for capital A without the subscript, the final amount will be 308.7. For A sub 0, that will be 203.3. And then we will have e to the power k, and for t we will have 40. So now to solve for this, remember what we're looking for. We are looking for k. And remember, k is called the growing entity. or the growing rate. So before we could solve for it, the 200, what is it, 203.3 do into E? Multiply, so it makes sense that we divide, correct? Now we have E to the power, and instead of writing K times 40, I'm just going to write 40K. It is the same thing because multiplication is commutative in that case. And now to solve for this one, we could go ahead and convert it to a logarithmic expression. If we do that, it will be log, or in this case, since it will be the base E, we could say ln of this number. Actually, let me do it this way so you guys can visualize what's happening. So if we were to take the natural log on both sides, what will happen on the right? So natural log and E, they will undo each other, right? They cancel. So we will get 40K as a linear quantity. And here we have ln of 308.7 divided by 203.3. And make sure you don't divide yet, just leave it like that. And then what is the 40 do into K? Multiplying. Good. So what we need to do here to solve for K, and we're just going to get an approximation, is going to be to divide ln of 308.7 over 203.3 divided over 40. And so you need to be very careful. This will be a candy opportunity. The first one to give me the answer. And I want you guys to round to, let's see. I would suggest that when you are doing your homework, you actually round to maybe take 4 places. Okay.
0.010442.
Okay. 0.01.
0.010442.
Okay, so let's round it like that. Okay, it's okay, guys. We'll have another opportunity for candy. Okay, so that will become the answer of part A. Well, not really that, but the answer will be, the question was find an exponential growth function. So our function will be the following. A is equal to A sub 0. We actually have an amount for A sub 0. It's here. We're going to go ahead and use that. So 203.3 times E to the power K times T. And we know what K equals to, and that is 0.0104? 04 times T. So that is the answer for the first one. When you are solving your homework on my math lab, make sure you read how many places they want you to round to, okay? Well, that would be the exponential model, and now in this case, you could, your unknown variable, to solve for it, you could either solve for A or solve for T, but you will have to be given either or, okay? So that's actually what we do on the next question, and the next question says, by which year, so now we're going to be looking for T, will the U.S. population reach 335 million?
Which A we found K?
Correct.
Well, my math lab asked, like, what's the answer for K?
They could either ask for just K or for the exponential model. All right, so now we're going to use the answer from part A to answer part B. So now that we have an equation for it, that will be A is equal to 203.3 times E to the power 0.0104t. Now the question is by which year? So we're going to be looking for T. That is our unknown. First we were looking for K, now we're looking for T. But we know that the final amount is 335. So in this case, we substitute the A with 335 and then we will have that. So now we're going to solve it like we did the other one. First we need to divide. And then we'll take the natural log on both sides. If we take the natural log on the right side, you know it's going to cancel with e, correct? Or you could just look at this problem as if I was converting it to logarithmic form. Okay, I see you guys are already working on the answer. That's good. So that divided by 0.0104, that would give us the value for t. Okay, so what's the answer?
48.0238.
Okay, and then pass it to what is the, say that again?
48.0238.
Okay, and then I'm going to go back and see how they want us to round and by which year. So let's just go ahead and take 48. And so remember that t equals 0 was the year 1970, right? So for t equals 48, what will that be? Anyone? Karina? 2018. Okay. 2018. So I want you guys just to quickly Google that. What is the U.S. population right now? Just to get an idea. So we are in t equals, we're in 2015, right? So that will be t equals what? 45. So let's see, what is the U.S. population right now? Maybe there's no, maybe 2014, but I don't know.
318.9 million.
318.9, and that is for 2015? 2014, okay. So we're looking at t equals 44.
For what year is that?
For this year, it says 320.09.
320.09? Okay, yeah, that makes sense. And the question was asking about what? 335 million? So do you guys think that makes sense?
Yeah.
Yeah, right? Okay, so for year 2014 is 318 million, for year 2015 is 220 million. So it is predicted that we will reach a population of 335 million by the year 2018. All right, so we're done with this part of the video. We will continue this lesson on Monday. And then Tuesday, I'm going to have a review session after school, okay?